Hello everyone, welcome to our channel S4 Eduvision by Snehal. So today we are going to discuss on concept of summary statistics, which is based on an organized and classified data. So I would like all of you to revise video 4 classification of data before starting with this concept. So let's quickly go through the roadmap of our today's video, which is summary statistics part 1. Here we are going to discuss on following topics. What do we mean by central tendency? What are different measures of it? What are the characteristics for a good statistical average? One of the average, which is arithmetic mean. How can we calculate it for individual discrete and continuous data set? And if the data set is continuous, how we can calculate average using two different methods, that is direct method and step deviation method. Let us understand the concept of central tendency with help of a simple example where a distribution of marks scored by 120 students are given. The marks are out of 80, and if you observe this distribution, we can observe that if we try to drawing the midpoints of the rectangles, we can find that data is around almost symmetrical. That is, most of the data is concentrated in the central region as compared to the tail regions, right? So, what the central tendency says? It is the general tendency to cluster or concentrate at the central part of the distributions. For example, distribution of marks, height of persons, etc. The question arises how to measure the central tendency, which is a single representative value which is summarizing the whole data set. And these are called average or local values. The commonly used averages are arithmetic mean, simple weighted, median, mode, geometric mean, and harmonic mean. Let us understand what are the characteristics required for a good statistical average. It should be rigidly defined, unambiguous, that is clear, and unbiased. It should be based on all the observations and should be resistant to extreme values or outliers. It should be easy to understand and calculate. It should not be affected by sampling fluctuations. And it should be capable of further algebraic treatments such as to do analysis. And it should be useful in real life contexts like income analysis, exam scores, or market trends. See how we can define arithmetic mean. So, arithmetic mean of a given set of observations is the ratio of sum of all observations to the total number of observations, and it is denoted by x bar. Now, can you tell me that can we use the same formula for all type of data sets? Have you thought on this question? The answer for it is no. If the data is of frequency type, we have to make some changes in the formula, and let us see how can we calculate it for different type of data sets. Let us calculate arithmetic mean for raw data or individual data. So if x1, x2 till xn are n values of a variable x, then the arithmetic mean is given by x1 plus x2 till xn upon n. For example, if a dice is rolled 5 times and we want to find mean number on it, then here we find that x1 is 1, x2 is 5, x3 is 1, x4 is 6, x5 is 2. And when we sum that observations, it comes 16, and by dividing it by 5, our value is coming 3.2, which is mean of the given data. And one more thing we will observe here, that though our data is of discrete type, mean is not necessarily be discrete. For ungrouped or discrete frequency distribution, if a discrete random variable capital X is given with values x1, x2 till xn and corresponding frequencies f1, f2 till fn, then the arithmetic mean is x1 into f1 plus x2 into f2 so on till xn into fn divided by capital N, which is total frequency of given data. For example, if a die is rolled 10 times, then mean will be calculated as 1 into 2 plus 2 into 3 plus 3 into 1 plus 4 into 2 plus 5 into 0 plus 6 into 2, which comes out to be 31. That divided by capital N, which is 10, and it will give you value 3.1, which is mean of the given data set. When it comes to group frequency distribution or continuous frequency distribution, we can calculate arithmetic mean by two methods, that is direct method and step deviation method. Let us see one by one. Let us understand step-by-step calculation for direct method. We obtain midpoints of each class and denote it by say xi, which is upper class boundary plus lower class boundary whole divided by 2. Then we multiply these midpoints by the respective frequencies fi and obtain summation of xi into fi. Then we obtain total frequency denoted by capital N, and x bar is sum of xi into fi whole upon capital N. Here we can observe that the formula to calculate mean is same as for discrete frequency distribution, only here we have to obtain midpoints of the dataset. Clear this with help of simple example where distribution of marks are given and we want to find mean for this continuous frequency distribution. So in this data we find that marks are in intervals and corresponding frequencies are given. We find midpoint of the classes by adding lower class boundary plus upper class boundary upon 2. So for first class it will come 5. For second class it will be 10 plus 20, which is 30, divided by 2 15, and so on. Then we obtain next column by multiplying xi into fi, and its sum is coming 1400. So mean is equal to 1400 divided by capital N, which is summation fi, which is equal to 50, and 28 is the mean of the distribution. In step deviation method, which is useful for finding the mean of a frequency distribution when class intervals are large enough or data values are big. Despite simplification, we can observe that the mean obtained is exactly same as with the direct method. And instead of working with large midpoints, you reduce them to a smaller numbers by choosing an assumed mean and then dividing by class weight. So handling smaller numbers makes manual computation easier and less error prone. Formula to get it is we sum f into u divided by sum f, then multiply it by h and then add assumed mean to it, where u is deviation of midpoints from that assumed mean upon h. Obtain mean for the same data set using step deviation method. So first step here is to obtain xi, which are the midpoint of the classes. Then we have to assume mean, say 25. Make sure it lies between your interval 0 to 50. And class width, overall we can see the difference between UCB and LCB is 10. So now we will calculate UI, which is equal to XI minus capital A whole divided by H. So for x1 5, u1 is coming 5 minus 25 whole divided by 10, which is equal to minus 2. For x2 15, u2 is equal to 15 minus 25 whole divided by 10, which is equal to minus 1, and so on. So now if you observe carefully, we can find that Fi into Xi, just observe the values are big as compared to Fi into Ui, which we can even calculate it without making use of calci. So with the help of the columns Fi and Ui, we have obtained the column of Fi into Ui whose sum is coming 15. Now with the help of the formula which is discussed, we can obtain the mean as capital A assumed mean 25 plus the summation Fi into Ui upon Fi, which is coming 15 upon 50 and into 10. Finally, we are getting answer 28, which is the mean of the data set, and it is same as we have obtained in direct method. If you have any doubts or queries, please post them in comment section so that we can discuss them further. In the upcoming video, we will study Summary Statistics Part 2, where we will discuss on properties of arithmetic mean with proof of combined mean of number of groups and effect of change of origin and scale. Also, we will see merits and demerits of arithmetic mean with limitations and its application. Thank you all for watching. Keep connected and revising. I will see you in the next video. Best of luck.